Hello and most welcome to 1272 of the series. We have a mixed sky today, as previously quite warm, very clement for the season. And actually there are leaves left. We are closing up to December next week, Thursday I think. And this, we even have a magnolia, I think it's called, the plant outside, still alive and kicking. And still alive and kicking is still also Roberto Unger, and I will continue with path taken. Singular universe, and we ventured into the mutability of the laws. So 1272. We began with the meta laws, and it's page 275. Now we'll continue a little bit mid into the page. Suppose that the change of laws of nature is itself governed by laws, higher order laws or meta laws. Then the problem of the historicity of nature and of its regularities will simply recur at that higher level. We will have gained little or nothing in our effort to recognize the inclusive reality of time, as well as the occurrence of a causality that may be lawless. Either we concede that the regularities of nature are themselves open to change, or we claim them to be exempt from time and change. We have simply postponed the problem or transferred it from one level of explanation to another. Suppose, on the other hand, that the change of the laws is not itself law governed, then it seems that it is uncaused, which is to say arbitrary, or at least without explanation, whether deterministic or probabilistic, then indeed the idea of a history of the universe would have driven us to explanatory nihilism. Those would have been right who feared that a full recognition of the reality of time would undermine the project of science. Note that this statement of the conundrum elides the difference between causal explanation and the explanatory deployment of laws of nature. It is written in a way that suggests that when explanation by reference to laws of nature fails, so must causal explanation. It is an unjustified elision. To question it is to arouse the first glimmer of hope that we can begin to overcome the conundrum of the meta-laws, showing it to be a false antinomy in our conventional understanding of causality. The laws of nature serve as grounds for causal explanations in the standard practice of physics, at least since the time of Galileo and Newton. No explanations are offered that fail to depend directly and explicitly or indirectly and implicitly on law-like regularities, symmetries and constants, as well as laws of nature. The pursuit of such regularities came to be considered the chief business of science and particular explanations of particular changes as simply instances of such regularities, especially of laws of nature. Yet in our ordinary experience, we regularly make causal judgments that assume some measure of stability in the workings of nature, but make no reference, however remote, to general connections like those that physics represents in mathematical language. To address what is at stake in the elision from causes to laws, that is implicit in my first statement of the antinomy. I now restate the conundrum in a second form. The form of an antinomy about causality. This second statement of the conundrum highlights its relation to the reality of time. Suppose that the laws of nature are in fact exempt from time and change, as almost all physics up to now has assumed. I have several times recalled how the physics of the 20th century reaffirmed the idea of a timeless framework of laws of nature in the very process of overturning the ideas of a distinction between natural phenomena and their background in space and time, as well as of sharp contrast between space and time. Our causal explanations will then enjoy a firm basis in timeless laws. However, it is a basis that we shall have secured only by qualifying the reach and the reality of time. The practice of the Newtonian paradigm exemplifies how time can be accorded some limited measure of reality without being allowed to go all the way down. That is to say, to touch everything that there is, so that everything can change. Under the view presupposed by the Newtonian paradigm, the laws of nature are not themselves marked by time or susceptible to change. It is because they are not so marked that they can support causal explanations concerning events in time. Suppose, on the other hand, that time goes all the way down or includes everything, with the result that the laws of nature may change. Then all our causal explanations are insecure. They are adrift on a sea of changing, or at least changeable laws of nature. From the vantage point provided by this second statement of the conundrum of the meta-laws, it seems that our conventional beliefs about causation, including beliefs that inform practices of scientific inquiry, equivocate about the reality of time. They take time to be real to some extent, to the extent necessary to allow for the reality of causal succession. However, they do not take time to be so real that no framework of natural laws can lie immutably outside time. Time, according to such beliefs, must be real, but not too much. The problem of causation in the early universe revisited. Before considering the general character of a solution to the conundrum of the meta-laws, I revisit the problem of causation and of the relation of causation to laws of nature as it presents itself in the early universe. The regularities of nature are there not clearly distinct from the states of affairs and the composite formed by the laws of nature and by the states of affairs may have been excited to a higher degrees of freedom and allow for a broader range of adjacent possibles than we usually, but not always, observe in the established universe. However, this circumstance, so disturbing to our habitual model of scientific inquiry, does not spell the suspension of causal connections. It fails to do so for two basic reasons. Each of these reasons turns out to be significant in the effort to understand the most promising way out of the conundrum of the meta-laws. The first reason is that the convergence of the regularities of nature with the phenomena that they govern in a composite arose to higher degrees of freedom and with a broader periphery of adjacent possibles need not imply the cessation of causality. It may signify instead that causality ceases to be lawful. It no longer works as recurrent relations among the elements of a discriminate, well-ordered structure. That nature in this condition exhibit more degrees of freedom, may be translated into the idea of a broader range of adjacent possibles around the present states of affairs. More theirs are accessible from the heres. That is, more theirs are accessible from the heres. Yet, as the regularities and structure of any earlier state of nature vanish into the great formative fire of the universe at its origins. There may be other more general constraints that causation continues to obey in moving toward one proximate possible rather than another. Such more general constraints maybe the ultimate regularities that we traditionally call principles rather than laws, such as the least action principle, or its twin, the principle of conservation of energy, or the equally fundamental principle of reciprocated action, according to which causal influence is always reciprocal. Even these principles, however, have limited domains of application in our established scientific ideas, as well as remaining as everything else does within the reach of time and change. The principle of least action is satisfied only for classical physics and fails in quantum physics. Conservation of energy is a contingent consequence of a symmetry under translation in time, and fails in general relativity. No hard and fast distinction exists between the effective laws governing phenomena in certain domains and these principles, which are also described as fundamental laws. However, although everything can change, some things change more slowly or rarely than others. The phenomena more easily and often than the effective laws, and the effective laws more readily and commonly than the principles or fundamental laws. The second reason why the circumstances of the early universe need not imply the breakup of causal connections is that in nature as we observe it, what comes before always shapes what comes later, even if the mechanism of influence may change. That it may change, and indeed will change, results from another general feature of nature pertaining to the character of time. That changes the two presuppositions of such a causal continuity, even in the extreme conditions of the early universe, are first the conjecture of the succession of universes, and second, the conjecture that in the very early universe, the values of the parameters of quantities of density, temperature, and kinetic energy are finite, although they are extreme. These two assumptions work together to establish the possibility of causal pass-through from one universe to another. Nature can work only with the materials at hand. All of them products of transformation, including the transformation of transformation, which is the character of time. Such a causal pass-through from one universe to another, stressed but never completely broken up by the conditions, characteristic of the very early universe, is compatible with the difference of one universe or one state of the universe from the universe or state that preceded it. Each successive universe, if there is such a succession, may have a different structure and been made up of different materials and display different laws. Everything in a new universe or state will nevertheless have been made with what existed in the old one, as filtered through the extreme circumstances of the formative moment. The earlier universe, or the earlier states of the present universe, may leave vestiges or fossils. Such may be, for example, the unexplained values of the constants, in particular the so-called dimensionless parameters of nature. Set aside those unexplained parameters that are intrinsically dimensional. Newton's gravitational constant, Planck's constant, and the speed of light. We are left with the others as candidates for the role of bearing the traces of an earlier reality. They include the masses and a ratio of the masses of the elementary particles, the strength of the different forces or interactions, and the cosmological constant. These dimensionless parameters count among the hieroglyphs in whose forgotten language we may one day be able to read the records of a bygone world. A premise of this approach to reasoning and empirical inquiry about the very early universe is the rejection of the idea of an infinite initial singularity. the infinite here as elsewhere would amount to an insurmountable obstacle to further investigation. It is an obstacle that we should not and need not willfully impose on ourselves. A mathematical conceit announcing a breakdown in the application of a theory to some part of nature and its history, rather than a description of any natural phenomenon. The best hope for resolving the conundrum of the meta-laws. This exercise in relating the conundrum of the meta-laws to the picture of the history of the universe that emerges from contemporary cosmology suggests where the best hope for resolving the conundrum lies. It lies in the combination of ideas that I have already explored, but have now only to bring together. In being brought together, they do more than suggests a general speculative view. They also serve as a basis for conjectures that can help inform an agenda of empirical inquiry. One idea is that of a change in the course of the history of the universe, in the relation between states of affairs and the laws to which they conform, and more broadly between two major variants or moments of the workings of nature in the history of the universe. With a causal succession between them stressed but never broken. As a result, present nature, even at its moment of greatest upheaval and transfiguration, is always able to work with a legacy bequeathed to it by past nature. A third idea is that the new laws of nature may develop coevally with the phenomena that they govern. A fourth idea is that this coeval transformation of the phenomena and of the laws may be shaped by higher order principles or fundamental laws. Such principles may themselves be subject to evolution. A fifth idea is that causality may exist without laws. Causal connections are primitive features of nature. In certain variations of nature, causality may fail to exhibit its familiar, recurrent, and law-like form. Such are the states associated with the very early universe in formation, or with extreme states of the cool-down universe. What we call laws of nature are the regular and recurrent form that causal connections take in certain states of nature or for certain periods in the history of the universe. It follows that we do better to think of the laws of nature as deriving from causal connections rather than to see the latter as deriving from the former, as we are accustomed to do. The existence of causality without laws is founded on the power of sequence, the influence of a before, on, and after It is an influence exercise regardless of whether causal processes recur over differentiated structure of reality. Allowing us to state laws in the form of equations. The ability to express laws of nature as equations provides an immense benefit to scientific inquiry. By the same token, however, this practice may mislead us into thinking of causal connections as mere instances of laws of nature. It is, on the contrary, the laws that describe one of the forms, but not the only form, that causal connections take in nature the recurrent and general form. In previous parts of this book, I have introduced each of these 5 ideas. Now is the occasion to show how they can work together and establish, if not a solution to the conundrum of the meta-laws, then a class of solutions or a marking of the conceptual space in which we can best hope to develop a solution. The first 2 ideas, the existence of radically different states of nature and the preference for a succession rather than a plurality of universes, set the stage for such a solution in a view of universal history. The third idea, the coeval change of phenomena and of laws, and the 5th, the priority of causation to laws, provide the key to a solution. The 4th idea, the way in which the evolution of effective laws may be shaped by fundamental laws or principles that evolve more slowly or that change only in more extreme circumstances.
qualifies and refines the third idea, that laws of nature may develop coevally with the phenomena that they govern, is a notion that arouses puzzlement when stated in a physical or cosmological setting. It is nevertheless an idea long deployed in two other domains: the life sciences and the field of social and historical studies. The regularities by which, I should take a cup of coffee here. The regularities by which we have come to understand the evolution of life with respect to Darwinian natural selection, and even more remarkably with regard to genetic recombination, arose with life itself. It was at the same time. I think this is an incredibly important clue. No one thinks about this simultaneity. No one. Once more, the sharpness of Roberto Unger. They do not suspend the laws of chemistry and of physics. They work through them. The physical constraints on body shapes and the pairing of structures with functions are, for example, a traditionally underemphasized element in the evolution of life forms. However, life, whenever or wherever it arose, represents something new in the world. Whenever or wherever it arose, represents something new in the world, with respect both to the phenomena that constitute it and to the regular causal connections, the laws that characterize it. In any attempt to reduce these regularities to the supposedly more basic laws of physics and chemistry. The strong reductionists has always found that whatever victories he wins are Pyrrhic. The interesting information about the kinds of things that there are and the way in which they function is left out of such reductionists' accounts. In the study of society and history, the idea that the phenomena and the regular relations by which we explain them develop together is a familiar view. It takes many different forms according to the conceptions of different social, economic, and political theories. For example, those who believe that there are types of social and economic organization, such as capitalism or the market economy, often hold that each of these types have certain laws and logic of reproduction and transformation that cannot be defied with impunity. A Marxist may claim that there are higher order laws commanding the historical succession of modes of production, and therefore as well of the sets of laws governing each of them. Yet those who have ceased to credit the more heroic claims of dialectical materialism with its idea of meta-laws have not believed themselves required to abandon the more limited claim that each new system of social and economic organization emerges together with its own laws. In this confidence they are matched by their conservative counterparts who think that the laws of a market economy are, with minor variations, always and everywhere the same. The belief that the laws and the phenomena develop in tandem, which we find widely expressed in the earth, life, and social sciences, may be puzzling, but it is not nonsensical. In fact, physics may be the only major science in which it is not a standard explanatory move. It is not because they make this move that the neo-Marxists and the practical conservative economists are mistaken, but for other reasons, including the idea that capitalism or the market economy represent indivisible law-like systems. These are other reasons concern the substance of their understanding of history and humanity. Part of the solution to the conundrum of the meta-laws lies in the introduction into physics and cosmology of the idea that the laws of nature may change and evolve in concert with change and evolution of the phenomena they govern. This coeval development of the laws and of the phenomena may occur more readily and rapidly in those moments in the history of the universe when the distinction between laws and states of affairs has broken down, or in which a differentiated structure has not yet emerged. However, it may recur later in the formed and cooled universe. Whenever and wherever something genuinely new happens. Of things new, the most astonishing to us, its products, is life, and then later the work of the imagination in society and in culture. Not only is life an emergent phenomenon, but it also becomes a means for the generation of more emergent phenomena. That is to say, more novelty in the world. It does so first through natural evolution, then through the conscious work of humanity. The joint transformation of the laws and of the phenomena is forceful and quickened in those states of the universe that witness a collapse of the distinction between the laws and the states of affairs that they govern. Causality, as I have argued in chapter 1, may exist without laws or not in law-like form. It is discontinuous or episodic in those conditions of the universe in which the laws have become distinct from the states of affairs. In either situation, however, the coeval change of the phenomena and the laws always works with the materials produced by sequence. It is, as the evolutionary biologists like to say, path dependent. These path-dependent materials include both the structure of nature and its regularities as they result from the prior history of nature. Moreover, some regularities are more fundamental than others. That need not mean that the more fundamental regularities are immutable. It means only for a view refusing to allow exceptions to the sway of time, that they change more rarely and marginally. On this conjecture, they can help shape the content and the evolution of the lower order or effective laws without being themselves timeless and changeless. They are therefore meta-laws in one sense, but not in the other. They can move without being themselves immovable. They are nevertheless the most stable part of nature. Although our understanding of them is subject to revision in the light of the advance of science. Our contemporary view of the content of these principles is a summation of the history of physics from the 17th century to today. Here is a non-exhaustive list of them, stated in loose conceptual order rather than in historical sequence. First among them is the principle of least action, which all by itself can support an alternative account of the phenomena explained by Newton's laws of motion. A second principle is the principle of conservation of energy, intimately related to the principle of least action. The conservation of energy, however, can be derived from the principle of least action only when there is a translation symmetry in time, as described by Newton's theorem below. A third principle is the principle of the equality of action and reaction, or more inclusively of the conservation of momentum. It can be further generalized in the form of the core idea in Newton's theorem that on the basis of any theory using a Lagrangian or a Hamiltonian to describe a symmetry, we can, once we specify the values of the variables, apply abstract algebra to infer a conserved quantity, be it a quantity of energy, linear momentum, angular momentum, or something else. In this generalized form, we might call it the principle of Newton. A fourth principle is the principle of the degradation of energy, the principle of Carnot. A fifth principle is the principle of the invariance of the laws of nature for fixed observers or observers in uniform movement. Galilean relativity. These principles, whether taken one by one or in concert, are not effective laws. They do not suffice to support particular causal explanation of particular phenomena. They have as their proximate subject matter the effective or domain-specific laws of nature, rather than the phenomena. Many, but not all, of the states of affairs that we observe in the established universe, and many, but not all, of the effective laws that science has thus far propounded, conform to all of them. In tandem, these principles or fundamental laws describe the most stable and universal aspects of the workings of nature. It does not follow, however, from their preeminent stability, and it's not required for their power to shape the effective laws that they be themselves either immutable or universal. We are faced in the present condition of our knowledge with a choice between two ways to understand them. Both of these accounts are speculative in the sense that we cannot directly subject either of them to direct empirical confirmation or challenge. They can nevertheless play a part in agendas of scientific research that are open at their ample periphery of implications to empirical confirmation or invalidation. In this sense, the two speculative accounts can also face empirical tests, indirectly by virtue of their share in such research agendas. The first understanding is that these principles are indeed an immutable framework of reality. This view gains force from the idea against which we argue in this book, that the universe of ours is only one of many universes, in all of which the same principles are realized. It also wins support and meaning from the notion that time is not all-powerful and all-inclusive. Something lies beyond its reach if only the fundamental laws of nature. The second understanding is that these principles are only relatively distinct from the effective laws, and thus as well from the phenomena. They form part of time-drenched and changing nature, although they represent the part that changes least or less often. The fire must be yet greater for them to burn. Nevertheless, they too can change. This second view makes sense in light of the two combined ideas that have been central to the argument of this book: the solitary existence of the universe and the inclusive reality of time. The most important attributes of the world is that it is what it is and not something else. It happens to be one way rather than another. The it that happens to be one way rather than another includes the effective laws of nature. The principles, or more fundamental laws, describe the way the effective laws happen to be. That is to say, their family resemblance, to use a Wittgensteinian phrase. We do not say, like the God of the rationalist philosophers, that the scandalous particularity of nature and of its history is the disguise of rational necessity. The universe happens to be one way rather than another in time, and it keeps happening and changing all of it, not just part of it. The coeval transformation or co-evolution of the laws and of phenomena hastened and extended in those states of the universe that are characterized by breakdown of the distinction between them, is shaped both from below and from above. It is shaped from above by the relative recalcitrance of the higher order laws or principles to change. It is shaped from below by the restrictive force of sequence, even at the extreme and testing limit of a non-cyclic succession of universes. The conception of co-evolution of the laws and of the phenomena informed by sequence or path dependence and constrained at any given time by the family resemblance of the effective laws, a resemblance codified as principles or fundamental laws, against the background of the conceptions of alternative states of nature and of a succession of universes suggests the beginning of a response to the conundrum of the meta-laws. These ideas fail to provide a definite solution to the conundrum, if only because they have yet to touch the ground of an empirical and experimental research agenda. However, they mark out a space in which to look for a solution. These ideas fail to provide a definitive solution to the conundrum, if only because they have yet to touch the ground of an empirical and experimental research agenda. However, they mark out a space in which to look for a solution. An aspect of this view requiring special attention is the relation between the idea of the co-evolution of the laws and phenomena and the idea of causality without laws. The way in which these two ideas operate together becomes clear only when both of them are developed and understood with acknowledgement of the different ways in which nature may work over the course of universal history. Such an acknowledgement begins in the rejection of the second cosmological fallacy. When nature may not yet be, or has ceased to be, organized into distinct and differentiated entities or elements, the distinction between laws and states of affairs may fail to apply, and the range of the adjacent possible may be large. The before may nevertheless continue to influence the after in time. This is incredibly important. Causality survives laws. Even the principles or fundamental laws may be subject to change, although less readily and rapidly than the effective laws. Causal connections, however, do not require that any part of workings of nature, not even the fundamental laws or principles, be unchanging. Their ultimate basis is not the laws, whether effective or fundamental. It is time. On the argument of this book, time and only time is what always remains. Everything else changes, including the ways change happens. These propositions, the residual and inclusive reality of time and the mutability of everything else, are not distinct propositions. They are equivalent formulations of the same idea. In guiding the co-evolution of the phenomena and the laws, the influence from above, the effect of slowly or rarely changing fundamental laws or principles, and the influence from below of sequence or primitive causal connections are, in this view, not at the same level. The former is variable and relative, the latter is radical and permanent. It borrows its power from time. This approach to the solution of the conundrum of the meta-laws has as one of its assumptions the primacy of historical explanation over structural explanation in all science, not in cosmology alone. Structure results from history rather than the other way around. It then both constrains and enables later historical development. No simple conflict holds between explanation from history and explanation from structure. From speculative conception to empirical inquiry. These are speculative ideas. They can, however, help inform an agenda of cosmological theory and research. Equipped with them, we can cross the frontier between the philosophical representation and the empirical study of nature. Natural philosophy, as we understand it, and here seek to practice it, outreaches what empirical and experimental science is yet able to establish. It does so dangerously with the intention of engaging the work of science. The conceptions presented in these pages about the singular existence of the universe and the inclusive reality of time do not lend themselves to instantaneous translation into scientific work. However, they are worth little if they cannot help inspire a new and better way of thinking about problems of contemporary cosmology, and through cosmology of physics as a whole. To deal with their bearing on these problems is a task that Smolin takes up in part 2 of the book. For the moment, it is enough to suggest that these views can inform a way of thinking about riddles that have become central to the scientific understanding of the universe and of its history. It is by their contribution to a more comprehensive and successful way of thinking about these problems that our speculative argument about the solitary existence of the universe and the inclusive reality of time can reach the front line of empirical and experimental science. The speculative leaps may be forgiven if they can be shown in the end to bring us closer to nature, as she so strangely happens to be. Consider briefly the feature of the history of the universe that our argument must principally be concerned to elucidate, if it is to show us its empirical value. Second, the range of practices that can test these conceptions along their periphery of empirical consequence. And third, the chief conceptual obstacle that must be overcome to advance in the development of such a research agenda.
Here, sorry. Time to round up. Well, Roberto Unger is here pointing to an alternative to the unchangeable, immutable laws, and another way of looking at these things. And I would say it has two advantages. We then never fall into the trap of reversing the induction. So to speak, start with the laws, consider them to be part of the universe, and say that they build up the world. And this is sadly how the multiverse has come up, Big Bang in its present form. We use the laws as levers
to get to new realizations. And I think pretty clearly Roberto, Unger, and later, as you will see, Smolin exposes this lie within knowledge, lie within understanding, and it leads to a specific way of understanding things that I would say is a non-understanding. Let me give you an example. Acquaintance of mine, Jan, is a firm believer in physics, and if you ask him what does he believe in, he said they know about space and time. So he pushed everything to a certain person or persons who he doesn't care what they come to conclusions about. But I always knew that he still has some pretty clear conceptions, and one of those conceptions is definitely immutable laws. Immutable laws, and I would say it shaped his life, it shaped his career, because every time he closes off time and space, which is in reality, according to Roberto Unger, he loses some insights. And it also has political consequences. He's a firm communist or socialist, so he believes in immutable laws also in society. And he also does believe in immutable laws in history. And although I don't think that is intentional, but once you get used to shoving off reality, ignoring it, you become habituated in perceiving the world as not real, imaginary, and of course, in those cases, your tendency to more and more shove the world away from you, to so to speak, not engaging in it, the more your lack of knowledge would trick you into departing even more from lived, experienced time. Roberto Unger has clearly pointed out, there can be no objects if there is no time. So you see, the very materiality of existence disappears. So no wonder he is an, well, could you say, pseudo-idealist. I don't think he has studied philosophy. He's an engineer as me. But I'm pretty sure he's leaning to some sort of transcendental idea of reality, which is actually shared by the scientists he believes are holding the truth. And he often says, it's all mathematics. I cannot understand it. Cannot understand his own lived reality. For some reason then, should time be in a special, different place, the mathematical place, and mathematics that doesn't recognize time, because as so clearly pointed out, time doesn't exist in mathematics. Mathematics is and always will be timeless. Therein lies its power of being able to do these equations and predictions, but it always indirectly assumes a static world, because logic and math never ever change, and they are not in parallel to reality itself. And no aspect of reality, doesn't matter if it's the sciences or history, sociology, psychology, ethnology, it will always be the same. Everything changes, including change itself. And the book clearly points out this hypothesis that changes itself cannot change, never been made. And I think that is revealing the big lie, or, well, it's worse than the lie, because it's not even a lie. It's just a big mistake or misrealization or misexperience. And I'm quite certain that this misexperience comes to us very early. If you grew up with a person, your parents, your siblings, that already shutting off reality, not moving in accordance with reality. I made a little filming the other day, I'll see if I can attach it, of students studying in the big reading hall at the Gothenburg University, and you can clearly see that they are in pain. They are blocking out their intellectual life in order to understand structure. So they voluntarily and willingly are leaving the world more and more, and they are tensing for every term, semester, more and more. This I remember. I started studying in '93, and I remember already a couple of years later people were more tensed. They lacked more energy and start falling into almost passive states of being where no energy came to them. The tension was obvious, but I never seen such tension as I saw in the reading hall yesterday. Hope I can add this. The whole body's tensed. This is people that learn to tense and repeatedly done it, enabled to, what they think, come closer to the structure. Little do they know, and little did I know, that the fault lies underneath, and there is no doubt in my heart that they know they are suffering, and it's tough because they are blocking out all intellectual power and destroying their bodies at the same time. So they must, like Plato and other philosophers like Bertrand Russell, feel the menacing torment of philosophies, strands of knowledge based on the unreality of the world. And this unreality that they try to sort of imitate, try to be the unreality, try to block all perception so they don't feel or sense anymore, so they can be living in a pure structural universe. And that would be okay. But Unger and Smolin shows that structure doesn't even make sense. It doesn't mean anything beyond the tensions and blocking out. If it had a meaning, that would be wrong. But it doesn't have a meaning. And each of these tensed people in the reading hall are living out their own individual cave. And they cannot even understand what they are themselves thinking. And I think this is brilliant. Bloom painted a picture of people not understanding their own thoughts and their own words. And they were just living out what they suspected or imitated to be knowingness from professors. And that changed, became more radical or stark in the living time of Bloom himself, that it developed exponentially. I would say in the mid-60s something happened. We stopped even the everyday understanding of an existence of time. Even that diminished to nothingness. And then it progressed starkly rapidly. A hippie movement was a confirmation of the invalidity of the world. It was an even bigger step into the transcendental world than happened in the 20s, where people were desperate from what happened in the Great War. Their parents disappointed. So of course they came to deny reality. And that was repeated even stronger in the late mid-60s to the early 70s, in the hippie movement, the age of Aquarius. You could see the mid-war crisis as a mini version of the age of Aquarius. I think that's fitting for the project. It makes sense. And leaving reality then became more and more the way of doing things. And I think that's transferred directly from parent to child, because you move in a completely different way if you every moment deny reality, deny the beautiful existence of everything in this world. So it's not a small thing that Roberto Unger and Smolin has started to do, is revealing the big fault and thereby going underneath the reactions that has been during history. Because there's no right and wrong to the hippie movement, for instance. It just needs to be healed, what is before. And then you freely can decide what you want to do. It was a lack of freedom. It was an automatic response of sorts. It's just, I'm taken aback a bit. I say thank you very much and have a very pleasant continuance of the short time that's left of the morning. Bye bye for now. Developed in time, caused by time, exposed by time. These are all beauty.